This video is on solving quadratic equations. We are going to solve these quadratic equations by factoring, and we're going to then use the zero product property. So in question 4, we see that we have a quadratic. It is set equal to 0. That means that we can factor this and then solve it. If we look carefully, question 4 is not in standard form. It does have two linear factors multiplied to each other. Therefore, this problem is actually already factored for us. This means that we can go ahead and go straight into the zero product property. We would take our factor of x minus 3 and set it equal to 0. We take our factor of x plus 6 and set it equal to 0. And then we would solve. So we would get x is equal to positive 3, and then x is equal to a negative 6. So it is important that you look to see what is the original problem written in. If it's already in factored form, then you can go ahead and solve it. If it is not in factored form, you need to make sure that you put it into factored form. The other important piece is that since it was already equal to 0, that told us that we could go ahead and set these factors equal to 0. If this was not equal to 0, we would not have been able to have done this at all. We would have had to have distributed our factors and then combine whatever our constant was over here. It would have taken a lot longer to do. On question 5, the problem is already equal to 0, but our problem is not in factored form, so let's factor this. First thing is our GCF. Our smallest number is 3. 15 can be divided by 3, so our GCF has 3 in it. We have an x and an x here, therefore, and that's all of our terms, so then our GCF would also include an x, because that's the smallest amount of x's. So we're going to divide everything in here by 3x. Therefore, we'll have 3x on the outside of a set of parentheses. When we divide, we'll have just an x, so 3x squared divided by 3x is x. Negative 15x divided by positive 3x is negative 5. And this is still equal to 0. So now we look to see if we can factor further. If we look inside of our parentheses, because we factor our GCF, the inside of our parentheses is an x to the first. Therefore, this cannot factor further because this is already a linear factor. That's good. Now that we have it factored completely, we can do the zero product property. We take all of our factors with x in it, so that includes the 3x, and we set them equal to 0. We have an x minus 5, and we set that equal to 0, because that x is included here. So in order to solve this, we would divide by 3, which 0 divided by 3 is 0. We can also know that 3 times 0 would give us 0. That tells us that x is equal to 0. On this next one, we would have adding 5, so we'd have x is equal to a positive 5. And I will note that if you have a GCF that includes the variable x, one of your solutions should be 0. So anytime you have to have a GCF with a variable of x, then one of your solutions will be 0, because one of your X intercepts will be 0, 0. On question 6, this problem is not equal to 0, so we need to get this equal to 0. Now, our x squared is on this side and it's negative. We could move all of this information to the right and keep our x squared negative, or we could just add our 3x squared to the left and make it a positive. That's what I would rather do, so that we would have a positive a. So I'm going to add the 3x squared to this side. I'm going to make sure I put it into the correct order. I need a positive 3x squared because we moved it to the left. Then I need my b value, which is bx, which is a positive 3x. Then I need my c, my constant, which is a negative 36. Now this is equal to 0 because we moved this negative 3x squared, we moved it to the other side. So we added it to the other side, and we just rearrange it so it is in the correct order. Now that it's equal to 0, let's look for our GCF, because we're factoring. The smallest number is 3, so 3 can be divided by 3, 3 can be divided by 3, and 36 can also be divided by 3. So our GCF so far is 3. We have an x, no x, so that means that we do not have a GCF of x. So let's divide everything by 3. So we have 3 parentheses, and we are left with x squared plus 1x minus 12. And this is still equal to 0. We still need to factor x squared plus x minus 12. So we'll have 3. And we're going to try and do 2 sets of parentheses equals to 0. Factors of x squared are x and x. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. So I'm going to start with the 3 and the 4. And I'm going to check. So this is just my work for this. I have a 3x here and a 4x here. So 4 and 3 can give me a 1 if I do 4 minus 3. So let's check the signs. I need a negative from the 3 and the x. So I'll make a positive x and a negative 3. And then I need a positive with the 4 and x, so a positive and a positive. So let's just double check this. 4 minus 3 gives me 1. And negative 3 times positive 4 gives me a negative 12, so that works. Therefore, these factors are in fact correct. So I can rewrite this into factor form by putting 3 parentheses x minus 3 parentheses x plus 4 parentheses equal to 0. Now that it's factored, I do the zero product property to find my solutions. So the 3 does not have a variable with it, so it is not a factor of x. I have an x minus 3 that has an x with it, so I set that equal to 0. X minus 3 equals to 0. And I have x plus 4, which has an x. I'll put that x plus 4 equals to 0. And now I will solve. I'll add 3 to both sides, so I'll have x equals a positive 3. And I'll subtract 4 from both sides, so I'll have x equals negative 4. So our two solutions here are x equals positive 3 and x equals negative 4. So there are 3 different but similar types of questions that you'll see. You will see the words that might say factor, find the roots by factoring, or solve by factoring. All of them have factor in it. So we will need to factor it, but then our answers will look completely different with regards to each of these problems. So the question that it'll actually say, so if it says to factor, the question will look like this: factor completely. Notice it does not say the word solve. The answer will look like this: parentheses, x plus 1, parentheses, x minus 4. You're going to have 2 sets of, or 3 sets of, or 4 sets of linear factors. You will still continue to see parentheses in your answer. If the directions say to factor, there is no equals anywhere. There are no equals in the problem, so there's no equals in your answer. So if it says to find the roots, if that's what it's asking, it'll literally say find the roots. What your answer will look like when it says find the roots, that's actually asking for the x intercepts. So you'll actually have it as a coordinate, -1, 0, and 4, 0. So you'll actually be looking for the x intercepts. Roots is another word for x intercepts. So you want to make sure your answer fits the question. Roots means x intercepts. We need coordinates. There are parentheses, but this is an x comma y. These are linear factors, so we're multiplying. If the words say, so if we're going to solve by factoring, the question will actually say solve by factoring. So since it says solve, you will have an equals in your question. You will have an equals in the problem. So the way your answers will look will be x equals, and then it's the x-intercept, then -1, only the x value, and x equals 4. So depending on what the question is asking you to do, depends on, or tells you what your answer will look like. So these 3 examples, the first one says just factor, the second one says find the roots by factoring, and the next one says solve by factoring. If you look at the differences in the original problem, factor has no equals anywhere in the problem. It has no equals anywhere in the problem. So we would just have our answer as two sets of parentheses with our multiplication. The GCF is 1, so this would be x and x. Factors of 3 are 1 and 3. And it's going to be a positive 1 and a positive 3 to get us to 4x. This is all your answer would be. If it says to factor, we want two sets of parentheses multiplied to each other. If it says to find the roots by factoring, it will give you the problem as f of x, because this is a y equals. I want to find the x intercepts from a graph, so I would have an f of x or a y equals. This is the difference between factor and find the roots. This has an equals, but it says f of x equals. So we would rewrite this by factoring. We would have f of x, we would keep that f of x or y equals. We're going to factor this, which we've already done, of x plus 1 and x plus 3, but we're not finished because it says find the roots by factoring. That's the method we have to get to it. Then we do the zero product property. X plus 1 equals 0, x plus 3 equals 0. We get the value of x equals negative 1 and x equals negative 3, but we have to put them, since it's find the roots, we have to put them as x intercepts. So this would be at negative 1, 0, and at negative 3, 0. Find the roots means find the x intercepts. So if we were factoring it, we have to keep the f of x equals, y equals, so that we know we're going to be looking at the graph of the problem. But for solving, same exact problem, but now it says equals to 0. That's the difference between finding the roots and solving. Finding the roots has a y equals or an f of x equals. Solving has equals to 0. So I want the solution. We still factor it because it says solve by factoring. That tells us the method that we're using. So we're going to factor this. Becomes x plus 1, parentheses, parentheses, x plus 3. But we keep it equal to 0. And then we apply the zero product property. X plus 1 equals to 0. X plus 3 equals to 0. We still get the x equals negative 1. And we get the x equals negative 3. So same concept, but now instead of putting it as an x-intercept, we actually write our answer as x equals negative 1 and x equals negative 3. So all of these problems are very similar in nature. It still says something about factoring because that's the method that we have to use. But the rest of it, so find the roots or solve, tells us we have to go one more step. Find the roots just means, hey, take this and find your x-intercepts. If it says solve, you're still doing the x-intercepts, but you're not putting it as a coordinate. So solve by factoring is one step less than finding the roots. And then factoring is one step less than solve by factoring because we don't have to continue with the equals. There is no equals in factoring. There is a y equals in finding the roots because we want to look at the graph of it to find the x-intercepts. And for solving, it's equal to 0, so we can find the values that will make it equal to 0.